Presenting now is Brad Yelland from BAE Systems. Brad will be presenting from the standpoint of a partner with DST for the delivery of science and technology capability for defence. Please welcome Brad. Thank you.
G'day, I'm Brad Yelland. I'm Director of Engineering and Technology at BAE Systems Australia. When I was asked to give a talk about, I was given the choice of either talking about collaboration or disruptive technologies, and I've been working in disruptive technologies for a long time. So that was the natural thing. But then I thought, actually, a lot of the disruptive technologies we've done in partnership with DST. So what I want to actually talk about is, and I think I've called it decades of collaboration success. So what I want to talk about today is just a little bit through history of where we've come from, what we've done, what we've achieved together as BAE Systems in its many guises. And I was just talking to a couple of people in the audience who were different parts of BAE Systems over the time. But I just want to talk about the history, just give a little bit of background of what we've done together, particularly focusing on the successes and why I believe that there have been successes and some of the lessons we can learn from that as we go forward into this pretty exciting time right now. So I've called it Decades of Partnering for Success. I'll start the story when I was a graduate engineer, which is 3 decades ago. So when I was a graduate engineer, I joined Government Aircraft Factories, and I started working on a project called Hoverock ComDev. To me, it was just a bit of a part-time thing, because what I really wanted to do, the reason I did engineering, is I wanted to design Formula One race cars. So I just needed a bit of experience in engineering, and then I was going to head over to Europe and sort of break into the world and become a Formula One designer. But what I actually started to get involved in was pretty damn exciting stuff. So Hoverock ComDev was an activity that was started really around a concept that was a joint collaboration between DST and then Government Aircraft Factories, which was the design arm of the defence side of things. It was done because there was a realisation, and the story behind this is really fascinating, and it'll take me a lot more than 30 minutes, so I'm not going to talk about that today. But the story behind it, it was a realisation that Australian ships were no longer safe against attack because of the advances in anti-ship missile technology. DST were given the problem to look at, and I can't remember what they were called, what DST was called back then. Yeah, but DST were given the problem of trying to solve this. What are we going to do to protect our ships? The solution they came up with was a EW, electronic warfare solution, to combat what is one of the big changes in the anti-ship missile technology was the sophistication of the seeker heads that allowed them to actually see through things like chaff. So chaff was no longer effective. And then the other problem was the missiles were all supersonic and they were sea skimming, and so the other line of defence, like CIWS, like phalanx gun, wasn't that effective either, because you could blow it up with a phalanx gun as it was coming towards the ships, and the bits and pieces of the missile still continued on and would still poke holes in the side of the ship because of the momentum behind it. So quite a significant problem. So the EW payload was all about not trying to destroy the missile. It was all about trying to trick the missile into thinking it was the ship rather than the ship itself. But the problem was the engagement happened so fast, and this payload needed to be off the ship. Then the problem was, how do you get the payload off the ship? Do you have a helicopter that sits out there? And if so, how long does it have to sit out there? And you need one 24 hours a day, which wasn't practical. So there was a meeting, pretty famous meeting, between DST and Government Aircraft Factories scientists and engineers, where they were discussing the problem, and one of the guys said, "Sounds like we need something like a hovering rocket." So HoverRock ComDev was born, and so started a really successful collaboration between DST and government aircraft factories on the development of this. A number of things happened in the world. One of them, there was the Falklands Islands, where Exocet missiles were used against British ships, but then the really big one was the USS Stark in the Gulf being sunk by a Chinese Silkworm missile. And the US realised they didn't have anything to protect themselves against these sorts of missiles either, and so they'd heard through the TTCP program that DST was working on a solution to the new generation of anti-ship missiles. Came to speak to them, and so the NOLCA contract was born. The significant thing, I think, for industry in all of this was that the US Navy were not allowed to contract an agency of a foreign government, so the contract couldn't go to the government aircraft factories. So a solution was looked for, and I'll have to. The automatic is working on the slides. So this is just a series of pictures of collaborations we've had with DST. So so it went out to industry. In order to make that work in industry, there really had to be this close tie between DST, between the Navy of Australia and the Navy of the US, and industry. That was 30 years ago. The contract was signed, the formal contract for NOLCA was signed in 1988. So it is the 30th anniversary of the NOLCA program. It's still going. It's still a collaboration program. It's on every US Navy ship. It's on every Australian Navy ship. And it would probably be on every ship in the world if it wasn't for the fact that it's so successful and so effective that there's an export ban. So we're not allowed to sell it to anyone else. That's probably a good thing. So that to me really showed the value of collaboration between industry and DST in industry understanding what defence needs, and defence being able to access the skills that industry bring to the table. So that's one example. Another example is JORN. JORN similarly has got a nearly 30-year history behind it. Another really good collaboration between DST and industry, and BAE in one of its other guises being one of the industries involved, and now we're lucky enough as of last year to be the sole industry partner, prime industry partner to defence on JORN. But JORN wouldn't have happened without the collaboration with DST. And that collaboration is still going, and we're still developing JORN, and JORN is now a very successful, effective product, and one that is getting a lot of attention as far as export customers go. So that's two really good examples of where collaboration that I've experienced myself, that the company I work for, BAE Systems, has experienced, where there's huge value in this collaboration. We've done a number of others. Evolved Sea Sparrow missile was another program we got involved in through our expertise that was demonstrated through NOLCA. We were contracted to develop the control systems and thrust vectoring control for the Evolved Sea Sparrow missile, which was a NATO program. Part of the program was to make sure that we continually engaged our scientific community in defence. And DST, we actually had a DST scientist sitting as part of our engineering team on Evolved Sea Sparrow missile. That program is also still going, and that program is going through continuous development, and that's another area where we work closely with DST. So the journey through NOLCA, and then through ESSM, and then the journey through JORN, which was happening at the same time, really showed to us the value of collaboration. This has continued, and if we take the JORN picture, the JORN story, we're now doing collaborations in new technologies that will further enhance JORN. There's a collaboration between the University of Adelaide, DST and BAE Systems around new clock technology. You might have seen the announcement yesterday around the new sapphire crystal oscillator That's an activity that has been focused on getting into Jawn and significantly improving Jawn. Some of the other successes we've had, collaborations on corrosion monitoring systems. We do the corrosion monitoring system for the F-35 aircraft, so all 2,000, 4,000, however many will be built, will have a corrosion management system that was developed by BAE Systems in conjunction with DST, leveraging the technology work that had been done in DST and BAE Systems, both in Australia and the UK. F-18 structural analysis. A lot of work was done in DST around the modelling, the fatigue modelling of F-18s. BAE Systems developed a structural health monitoring system that is extremely effective and still today is a world-leading technology. We've been putting some of the capability into F-35. That couldn't have been done without the partnership between DST doing the modelling and understanding the structural issues and us developing the method of sensing the structural issues. And I should add, that's one of the technologies that's keeping our classic F-18s flying today, because we were able to manage the structural health of those aircraft to the point where we know exactly how much life they've got left on them. There's other collaborations going on now around advanced sensors between DST and BAE. We're doing sensors, electronic warfare sensor technology. We're doing SPAD technology, single photon accumulator device technology. We're doing DIRCMs, infrared countermeasures. All of these are in various levels of maturity. The DIRCM is now a product that's being sold as an export product out of Australia. So a lot of mix of different types of collaborations and different types of successes. The other areas you would have seen up there was some photos of CubeSats and things like that. There's a lot of work we're doing in regards to 3D printing and the benefits that we can bring to things like CubeSats of doing 3D printing. We're working on hypersonics technologies together, so we're providing the guidance and control and the modelling capabilities behind the HIFIRE program, and that will hopefully develop into another successful activity. Over the years, there's been a lot of programs, that are successful, and there's a bit of a pattern that's been set up. And so what I want to talk about now is what we've learned from that and how we can use that to make sure we're successful in the future. So if I go to another technology where there was a little bit of collaboration with DST, a lot of collaboration with universities, and there's one representative sitting in the audience today of that. We did a lot of research into autonomy. And this was it started back in the late 90s. People think autonomy is the new thing. Actually, it's been going for well over 20 years. We've been working in this area. We did a lot of research. We did it with University of Sydney. We did research with RMIT. We did some research with DST. We did collaboration work with our aircraft group in the UK. And you see some pictures of activities there. We did a lot of demonstration activities, a lot of very successful CTDs where we were demonstrating collaboration between multiple UAVs doing complex missions, between unmanned ground vehicles and UAVs doing complex missions. We did demonstrations of stealth combat UAVs. In fact, we had the technologies in autonomy to the point where on some of our UAVs we could set them a mission, turn them on, and then hands off. They'd do the mission, they'd taxi out, they'd take off, they'd do the mission, they'd come back, they'd land, taxi back into the hangar and download their data and turn themselves off. So true autonomy we're talking about. We did autonomy around data fusion techniques, around target tracking techniques, a whole lot of different technologies that were really world-leading technologies. And this is, I'll remind you, it was late 90s, early 2000s is when we were doing this technology. and that's one of the demonstration vehicles that we used for it, flying out at Woomera. It actually never went anywhere. So we had this great technology. We had CTDs that were highly successful. We proved everything that we set out to prove, mature technologies, but it didn't go anywhere. One of the big opportunities to take Australian technology into the Australian Defence Force was one of the UAV programs, JP129. Our defence customer decided to buy FMS. Which is his prerogative, and it was probably a good decision and all that sort of stuff. But to us, it really taught us a lesson, and that is, if you're going to invest, and to give you an idea of the investment, BAE invested $50 million over the time in development of autonomous technologies. If you're going to invest in disruptive technologies, in leading technologies, you need to have your customer on board. So you need to have the end user customer on board, because it doesn't matter how successful it is, if the end customer hasn't got a need for it, it's not going to be a disruptive technology. It's not going to be a useful technology. So that's a really powerful lesson, I think. So we're about to enter into a period of significant investment in defence technologies. The whole Next Generation Technology Fund, I think, is an absolutely fantastic approach. That linked with the Defence Innovation Hub that allows us to develop sort of low TRL technologies, bring them through to maturity, get them into the Innovation Hub and really demonstrate them. That's a really great process. But unless there's an outlet at the end of that pipe, we're going to have the same problems. So we need to get the end user engaged right up front to make sure that where we're investing the money is something that he's going to use when it comes out the other end of the pipeline. That's all I really want to say on this. I think there's some fantastic promise. There's a lot of other areas that we, BAE, are working with DST on. There's a lot of other areas that Defence is investing in through the Next Generation Technology Fund that other industries are involved in. But I think in order to make the most of this unprecedented level of investment that we're seeing, and in order for that to turn into something that becomes a growth industry for Australia and generating a contributor to the economy, then we need to make sure we close the loop with the end user. So that's all. Thank you. Yep.
All right, we've got about 10 minutes for any questions. If you could just remember to raise your hand, and we can come around with a roving microphone if anyone has any questions.
Hi, Brad. Jeremy from Clearbox Systems. You talked a lot about your collaboration you've done over the years with DST. Could you give us some examples and your thoughts on how BAE collaborates with other industry, SMEs, mid-tier primes, top-tier primes?
Yeah, we've got a network of 1,600 suppliers, Australian suppliers in BAE, which we're very proud of. Something like 70% of the business we do through the supply chain, so it flows through BAE into the supply chain. We could just take the approach that we're just going to buy product, and if it's good product, we'll buy it. If it's useful product, we'll buy it. But actually the approach we take is we like to work alongside industry, particularly SMEs, to ensure that they understand what we need, that they're developing in the right direction, that we're supporting them in their development, so that they become more like a strategic partner to us. So can I name some? Yeah, there's so many. There's companies like Quickstep who are really successful. Moran, who are really successful off the back of programs that BAE Systems has worked with them on, like F-35, like Nolka. They've really generated some really good stories in Australian industry. We're working with Darrenmont on Jawn, the photo that's here. Darrenmont's one of our key suppliers, key subcontractors. There's 1,600 of them. There's a huge amount, but we're always looking for more. So So one of the things where we have the lead role on the industry lead role on the land side of the autonomy CRC. What we've been talking with the CRC guys about is setting up a process, and talking with Army and talking with DST, setting up a process where we work with Army, so that's the end user, getting the end user in place, with DST, BAE, pulling together a roadmap for technologies, and then going out to industry and saying, these are the problems we need to solve. Who's got some good ideas on it, who'd like to have a go at trying to solve them. So we're trying to be more engaging right up front with industry. John.
Hi, I'm John from Fraser Nash. A lot of these are defence related. I'm interested in the importance that you would place on non-defence uses. For example, autonomy in mining and resources. That seems to be an untapped market. So the whole dual use thing, what's your thoughts on that?
So that's the reason I'm smiling is, and I notice Casey Wong up the back there is smiling as well. That's a really good demonstration of how important it is to engage the end user. The answer I'm about to give you. I spoke about all the work that we did in autonomy. Absolutely world-leading stuff we did around navigation techniques, around collaboration techniques, all sorts of different technologies. We had a good arrangement with the university. University of Sydney, the Australian Centre for Field Robotics. Part of the arrangement was, the core IP was BAE Systems IP, but the university could go off and use that IP and develop it and use it, as long as it wasn't in defence. So we were happy for the university to go off and do that, and we were focusing on defence. And in those days, to be truthful, we thought defence was going to be the user of autonomy, and the rest of the world was going to take a long time. The only place that this technology has really been used is in the customers that the University of Sydney developed through the ACFR around mining. So the Rio Tinto mining autonomy work that the university has been so successful in doing, the root of that work was in the work that we did that was originally focused around defence technologies. So there's huge applications. As a company like BAE Systems, we're a defence company. We have some fantastic technologies that are useful in adjacent markets. All sorts of adjacent markets. You can look at infrastructure, you can look at oil and gas, you can look at mining, you can look at emergency response, border patrol. There's so many different areas that you can use a technology like autonomy. But what we have learned over the years is, as a defence company, we know the defence customer really well, but we don't know those other customers really well. So we're actually right now going through a process of saying, should we be looking at other markets? We're in a bit of a boom in defence, and when you're a company like BAE Systems and just picked up a $35 billion ship program, and you're focused on delivering for defence, but we're also conscious that bubble's going to burst soon, and if we don't plan ahead, then we're not going to be in a good position at the end of all that good work. So there's lots of opportunity. It's how you prosecute it, and one of the things that we're very keen to do is to link up with industry that works in the different areas outside of defence to understand how we can leverage our technologies through them into different markets.
Thanks, Brad. My name's Kamal Sidhu. I'm from the Defence Export Control Branch, but I've got a question more about UAS and autonomous systems.
You're not gonna ask me about
so that's from a previous life. My interest is in UAS regulation and certification.
Okay.
You mentioned autonomy has been around with BAE Systems, and you've been involved for a very long time, 20 years you mentioned. What are your views on the need to make or develop certifiable unmanned aerial autonomous systems so that we can, to the customer, provide a UAS or capability that is giving us the same level of reliability and safety as manned aircraft? Mm-hmm. We've been working on UAS for a very long time, but we don't have a certified UAS to date?
So, just cycle through this thing here called Tyrannus, fully flight certifiable, built to do DO178, be only level B, not level A, because we're only flying it in restricted areas. And every time you go up a letter, it adds you can triple the price of the development of it. We did the work with UK MOD. It's a complex process. It's a costly process, but it's easily achievable. The problem to me isn't the development of certifiable unmanned systems, autonomous systems. The problem is getting them certified. And the difference is that you've got to have the regulators willing to certify. And in order for the regulators to be willing to certify, you've got to have a general public who's willing to accept it. And that's the real problem area, is getting the general public to accept it. Every time something goes wrong with an unmanned aircraft, it's because of this demon autonomous technologies. Every time something goes wrong with a manned aircraft, it's human error, pilot error, it happens. I had, probably 15 years ago now, we were setting up in a facility in West Sale to fly our UAVs. And we wanted to start to integrate it with the airspace, and it was a great spot because half the time it was military airspace, the other half it was civil airspace, half the time controlled by the RAF, half the time controlled by air traffic control at Tullamarine. So we went to CASA and spoke to them about what we needed to do, and sort of progressive experiments of gradually flying the UAVs higher and higher and further away and further away. And but one of the interesting discussions we had was a question they asked of me was what happens if your UAV is confronted with a situation that you haven't designed it for? And that's a good question, and the answer is that we try to understand all the different circumstances and then allow for the unknowns, and we build that into the safety cases, and we build in a probability of coming up against the unknowns, and therefore allow for it in our total safety case. But then I turned the question around to them and I said, what happens if a pilot gets confronted with a situation he hasn't been trained for? And the answer was, well, he's a human, he'll work out what to do. So that to me is the nub of the issue. And when we can get around that issue, then we're really in a place that we can properly consider certification. Until then, it's going to be a gradual process of building the confidence in the general public. There's another little anecdote I love telling, and am I going to run over time? I'll just do this and we'll finish. Another little anecdote, and that is that back in 2006 there was an analysis done on flights into Heathrow Airport. The figures were, and these are not exact, so don't quote me on them, but something like 80% of the flights into Heathrow Airport were done completely hands-off by the pilot. The 20% where the pilot actually flew the aircraft at some point, they only did so because they wanted to, not because they needed to. But the real interesting statistic is more than 50% of the flights that were landed without the pilot touching it, just fully reliant on the autonomy in the autopilot, more than 50% of those were in conditions where a pilot wouldn't be able to land it. So that to me, I'm an engineer, you do your analysis of the data, you say, actually I'd rather have an autonomous pilot in there rather than a human pilot. The best is to have the combination, but if I had to choose one over the other, I'd choose the autonomous pilot. But I think even I would think twice if I was walking down the air bridge to get onto a plane and the flight attendant said, we're giving you a discount on your ticket today because we've decided we don't need a pilot anymore. I don't think I'd hop on that plane. So there's a bit of a stigma attached. So we've got to get over that, and the only way we can reasonably get over that is to do the work to convince the general public that we understand what we're doing and it's safe. Sorry.
Thank you very much, Brad. That
Okay.
was fantastic. Scary anecdote at the end. And as a token of our appreciation for your participation in Syndicate,
Thank you
have
very
that.
much.
Thank you very much.
Thank you.
Please.